Hello children, welcome to my YouTube channel Tarangan. Myself Dr. Panduranga Darekar. Today I am going to help you to learn a new topic, laws of motion. Let's start with the help of a question. Observe the picture and help the child to reach up to the ball in a shortest pathway. Can you? The picture involves two ways or two paths. One is shown with the help of red color and another way is shown with the help of blue color. What do you think? Which path is the shortest path? Yes, you are right. The path shown by blue color is the shortest path. The child may go from A to B and B to C. But in this method, the child has to cover 70 meters. But instead of that way, if the child go directly from A to C, child has to cover only 50 meters. Let's have one more example. Observe the picture and help the child to reach from point A to point B. Here, three pathways are shown to you. The green one, red and black. In which pathway the child has to cover shortest distance? Whether green or red or black, or the last, which is shown with the help of blue color. The child, if it goes on red path, the child will reach in a shortest way. What you have learned from above examples? We were discussing about distance and displacement. What is distance? Distance is the actual length, or it is the actual length of a path traveled by an object when moving from one point to another point. But displacement is the minimum distance between starting and finishing point. Let's go back to the pictures. In this picture, if child goes from A to B, B to C, it is the actual length. It can be called as distance. But if you see the blue path from A to C, as it is the shortest path between the starting point and initial point, this 50 meter distance can be also called as displacement. In this picture also, the red colored path shown in this picture is the shortest distance between starting and finishing point, so it is called as displacement. The other pathways shown with the help of green color, black color and blue color, they involves distance, not displacement. Let's resume to our difference. Distance is a scalar quantity. Why? Because direction is not needed to express the distance. Hence, distance is a scalar one. But displacement requires direction to express. Hence, displacement can be called as a vector quantity. Distance is always positive. It cannot be negative or zero. You have to notice that the actual length between 2 points is always positive. It never be negative or zero. But the displacement can be positive, negative as well as zero. The SI unit of distance is meter and the SI unit of displacement is also meter. Let's try to explain the third point with the help of some pictures. Answer the following questions. See, initially there is a car standing at point A. Now the car reaches to point B. What is the distance and displacement covered by the car? The distance covered from point A to B is equal to 12 meters. And the displacement covered from point A to B, it is also 12 meters. Answer the questions. See, the car has reached up to point C. What is the distance and displacement covered from A to C? The distance covered from point A to C is equal to 12 meters from A to B and 11 meters from B to C. That is total 23 meters. But what is the displacement? Displacement will be also 12 plus 11, 23. See the next picture. The car has reached up to point E. Now what is the total distance and displacement covered? The total distance covered from point A to E is equal to 12 plus 11 plus 10 plus 9. The sum is equal to 42 meters. And the displacement covered from point A to E is also same. 12 plus 11 plus 10 plus 9 is equal to 42 meters. In all above examples, you had noticed that the distance and displacement were same because the car has not changed any direction and the car was moving in a same direction. Now focus on next examples. See, the car started from point A, it reached a point E and it came back up to point D. Now what is the distance and displacement covered? The distance covered from point A to E and again from point E to D is shown and the total distance is 51 meters. Now let's try to find out the total displacement. See, while moving from point A to E, the car has not changed direction, but while moving from E to D, the car has moved in opposite direction. In this way, the total displacement from A to E was 12 plus 11 plus 10 plus 9. But as the direction from E to D is opposite, the displacement from E to D is taken as minus 9. So, the total displacement covered is equal to 33 meters. Let's have few more examples. Now the starting point of the car is A. The car is moved from A to E and came back up to point B. Now calculate total distance and displacement. See, while calculating the distance, we don't consider direction, so we have to add the actual length covered by the car. So while going from A to E, the distance is 12 plus 11 plus 10 plus 9, and while returning from E to B, the distance is 9 plus 10 plus 11. So the car has covered the distance of 72 meters. But while calculating the displacement, we consider direction. And the direction from A to E and from E to B is exactly opposite to each other. So the displacement covered from A to E is 12 plus 11 plus 10 plus 9, but while returning, the displacement from E to B was minus 9 plus minus 10 plus minus 11. Hence, the total displacement in the total traveling is 12 meters only. The last example. See, the car started from A and came back to point A. What is the total distance and displacement covered? The distance covered from A to E is 12 plus 11 plus 10 plus 9 meters. And while returning, the distance is 9 plus 10 plus 11 plus 12. See, we are not considering any type of direction here. Hence, after addition, the total distance is equal to 84 meters. Now let us calculate displacement. While calculating the displacement, we consider direction. First of all, let us try to find the displacement from A to E because it is in same direction. From A to E, the car has covered the displacement of 12 plus 11 plus 10 plus 9 meters. But while returning from E to A, the direction is exactly opposite. So, the displacement covered in the opposite direction is taken as minus 9 plus minus 10 plus minus 11 plus minus 12. Hence, the total displacement is equal to 0 meters. I think now you have understood that the displacement can be 0 or negative or positive, but distance is always positive. Observe the following picture. There is a circular path, and if Krishna is running on the following circular path, what will be the total distance covered by him in one round? If you observe the diagram, you may see that diameter of that circular path is 70 meters. Krishna is running on that circular path. To find out the total displacement or distance in one round, just we have to calculate the circumference of this circular path. See, when Krishna starts from point A and if he returns on point A, he has completed one round. And the distance covered in one round can be calculated by finding out the circumference, and the formula for the circumference is equal to 2 pi r, or Simply pi into diameter. Let's go to the second question. What will be the shortest distance to go from point A to B? Krishna is standing from point A and he has to reach point B. What will be the shortest distance? He has two ways. Either he can go from the perimeter or the circumference, or he can go through the diameter. So, traveling from the diameter will be the shortest path from A to B. Now we'll go to the next part of the topic, speed. What do you mean by speed? Speed is the distance traveled by an object per unit time. I repeat once again. What is speed? Speed is the distance traveled by an object per unit time. We may have the different definition. The speed is also called as the rate of change of distance. Speed is calculated with the help of the formula. Speed is equal to total distance traveled upon the time required. The same formula we are going to use to solve some numericals. Next part is velocity. What is velocity? It is the rate of change of displacement. I repeat, the velocity is also called as the rate of change of displacement. If the distance is traveled in a particular direction by an object in unit time, that distance is also called as velocity. Velocity is calculated with the help of total displacement upon time required. Note down the formula because we need this formulae to solve the numericals. Now let's have the difference between speed and velocity. As you had understood the definitions, speed is related to distance and the velocity is related to the displacement. See, speed involves distance. Distance was the scalar quantity. Hence, to express speed, direction is not needed and hence the speed is also a scalar quantity. On the other hand, velocity involves displacement. Displacement was a vector quantity and hence velocity is also a vector quantity. The formula to calculate speed is total distance traveled upon time, and the formula to calculate velocity is total displacement upon time. The SI unit of distance is meter per second and the SI unit of displacement is also meter per second. The CGS unit of speed is centimeter per second and the CGS unit of velocity is also centimeter per second. Now the similarity. If the motion is along a straight line, the values of speed and velocity are same. I repeat, if the motion is along a straight line, in the sense there is no change in a direction. So the values of speed and velocity are same. Now observe the table carefully. In this table, the distance covered by Amar, Akbar and Anthony is given. And on the left hand side, the time is also given If you observe the table carefully, you may notice that the distance is calculated after the gap of 30. Now, let us go to the first type, uniform motion. Observe the table carefully. You will find that the table shows you the distance covered by Amar. First, we will focus on the time intervals. See, in the column of type, the first time interval 5 o'clock to 5:30. The time interval shows the gap of 30 minutes. The next time interval, that is 5:30 to 6, it also shows the time interval of 30 minutes. In the same way, 6 to 6:30 and 6:30 to 7, they shows the gap of 30 minutes. Similarly, the next time interval. So, in this table, we can tell that the time intervals given has equal. Let's focus on the distance covered then. See, the distance covered in each half an hour, we are going to focus now. The first 0 to 20, that means Amar covered 20 kilometers in first half an hour. In next time slot, 20 kilometers to 40, that means again he has covered 20 kilometers. Now, in the next interval, 40 kilometers to 60 kilometers. Now also he has covered 20 kilometers. In similar way, if you calculate, in each time interval, the distance covered is also equal. Hence, in this way, we can conclude that if an object is covering equal distance in equal time intervals, then the object is said to be moving in uniform motion. See, two things you have to clarify here. The time intervals must be same, and in that time interval, the distance covered should be also same. Then and then only we can tell that the object is in uniform motion. Let's move to the next type, non-uniform motion. We will clarify it with the help of one more example. See, the table in front of you shows the distance covered by Akbar. Here also, if you see the time intervals, each time the time interval is made up of 30 minutes. The same example of previous one. Now we'll move to the distance covered. See, if you see the first slot, in the first slot 0 to 18, that means in first half an hour, Akbar has covered 18 kilometers. In second time interval 18 to 36, again he has covered 18 kilometers. But if you see the third time interval, in third time interval, Akbar has covered only 6 kilometers. In the next time interval, he has covered 18. Further, he has covered 25 kilometers. And in the last time interval also, he has covered 25 kilometers. If you observe carefully, you may notice that the distance covered in each time interval is not equal. So we can conclude that if an object covers unequal distance in equal time intervals, I repeat, if an object covers unequal distance in equal time intervals, then the object should be said that in non-uniform motion. In this way, can you identify the motion of Anthony, whether it is uniform or non-uniform? Can you try? Hurry up. Now see, identifying the type of motion in following cases. The motion of an vehicle on a mega highway where the traffic is very low, the road is clear, it is smooth and without any obstacle. Consider the vehicle is obeying the traffic laws of highest speed. Can you tell me the motion of such type of vehicle? Definitely, in this case, the motion will be uniform. Once the car reaches the maximum speed, there is no need to reduce the speed because there are no obstacles or the road is also clear and smooth. In second example, the motion of a vehicle in a crowded road. If the road is crowded, then the vehicle is driven with utmost care. So the speed might be increasing sometime, or because of obstacles or crowd, the driver has to reduce the speed time to time. So we can say that the motion of a vehicle on a crowded road must be non-uniform. Now let's move to the acceleration. Just answer the question. If you switch on the fan, it will start rotating. But if you suddenly stop it, will fan stop immediately? No, the fan will not stop immediately. Second example. If a car is moving with the velocity of 20 meters per second and applies immediate brakes, will the car stop on the spot? No, even after applying brakes, it will cover some distance. Why such things are occurring? Because we can tell that in the moving car or in the moving fan, acceleration is produced. What is acceleration? Acceleration is nothing but the rate of change of velocity. See, we have many examples where the motion is non-uniform. If a car is parked, it is at rest. So obviously its initial velocity is 0. If the driver starts the car and if the speed changes, then it may be the example of non-uniform motion. If a vehicle is moving with a particular speed, initially you may consider any speed and it applies brakes. Then the speed decreases and it comes to rest. Hence the final speed is 0. All these examples were of non-uniform motion. Whenever the velocity changes, the acceleration is generated in the object. The rate of change of velocity is called as acceleration, and acceleration is calculated with the help of acceleration is equal to velocity change upon time. Remember this formulae because we need it while solving the numericals. Suppose the initial velocity of an object is u and in time t its velocity changes to v. So the final velocity is v. Then the formula of acceleration can be written as acceleration A is equal to final velocity minus initial velocity upon time. Final velocity is v and initial velocity is u. So the formula becomes A is equal to v minus u upon t. Now the acceleration can be positive negative or 0 also. Let's find some circumstances where the acceleration is positive, negative and 0. Suppose a car is parked and if you see its initial velocity, obviously the velocity will be 0. If the driver starts the car and if it takes some speed, then from 0 its speed has changed to something. In this case, the speed or the velocity has increased. Whenever the speed changes and whenever the speed or velocity increases, the example is of positive acceleration. On the other hand, if a vehicle is moving with a particular speed or velocity and if it is apply brakes, after applying brake, either the speed is reduced or the vehicle may stop. That is, velocity of the vehicle decreases. In all such cases where the velocity decreases are the examples of negative acceleration. And the last one, if the velocity remains unchanged, that means if the car is moving by the velocity of 20 meters per second, in whole 1 minute, if it continues with the same velocity, then within that 1 minute, the acceleration must be 0 because there is no change in the velocity. Next, let's move to the graphical representation of uniform motion. See, the graph in front of you will show the distance and time relation of uniform motion. As you see the two columns, the first column is of time and second column is of distance. If you focus on the column of time, you may observe that the time interval is equal in each cases. The time interval is of 10 minutes. Now focus on distance covered. If you observe the table, this table shows the vehicle or the object is in the uniform motion. In each time interval, the object is covering 15 meters each. Let's try to plot the graph. To plot the graph, we'll take time in seconds on x-axis and the distance in meters on y-axis. See, on x-axis we had taken the unit of 10 seconds and on y-axis we had taken the unit of 20 meters on y-axis. If you plot all the points, you will observe that the graph shows a straight line. That is, the distance time graph for uniform motion is always a straight line. Can you try to plot the graph with another examples? Now see the distance time graph for non-uniform motion. Observe the following table. This table shows time and distance. On left hand side, if you focus on the first column, it shows the time interval of 5. Each time interval is made up of 5 seconds. Now focus on the second column, distance. In each time interval, if you observe, the distance travel is unequal. So this is the example of non-uniform motion. Let's try to plot the graph. In the same way, when you plot the graph, taking time on x-axis and distance on y-axis, you will not get a straight line for non-uniform motion. So, for all non-uniform motions, the distance time graph is not a straight line. Let's try to move the velocity time graph for uniform velocity. Consider a train is moving with the uniform velocity or speed of 60 kilometers per hour. If its velocity time graph is plotted on the graph will be also is a straight line. If you observe, the straight line intersects the y-axis at 60 and this straight line is parallel to x-axis. Now we'll see the velocity time graph for uniform acceleration. If the velocity change is equal, then the motion is said to be uniform motion. In such cases, the acceleration produced is also uniform. And if the uniform acceleration is there, the velocity time graph is plotted. The velocity time graph is also a straight line. In this way, we had completed distance, displacement, speed, velocity, uniform motion and non-uniform motion, acceleration and all the graphical representations of uniform and non-uniform motions. I hope that you had understood all the concepts. Read the textbook thoroughly. We will visit in the second video along with the equations of motion. So, thanks for watching this video and do visit Tarangan frequently to learn the concepts of science easily. Goodbye.